In this video, we will discuss the problem search in a row column sorted matrix. The problem says that we'll be given a matrix of n cross m size and each row and column is sorted in increasing order and we have to find the element x if it is present in the matrix or not. So how can we solve this problem? You can observe that first row is sorted in itself. Second row is also sorted, third row is also sorted. So all the rows are sorted here. Now notice one more thing, that all the columns are also sorted here. Now what will happen here? If you will see, so we can basically compare the element x with every element of the matrix and we can check whether the element x is present in the matrix or not. Now if we compare the element x with every element of the matrix in the worst case, so this is going to take how much time? The time complexity for the comparison will be order of n into m, because we'll be iterating throughout the matrix here, and the space complexity will be order of 1 for such an approach. Okay, you can see that we'll iterate for every element ij, we'll check if it is equal to x, return true, otherwise at the end return false after checking all the elements here. But can we do it more optimally? Yes, we can do it more optimally by having some observation here. Now what we can do is we can optimally solve this problem by eliminating a particular row or column. How? Understand one thing, that suppose if I start from this cell, okay, if I start from this cell and let's say I have to search for the element 35. Now 3 is less than 35. I know that 3 is less than 35. If I start from index 0, I0 and J0, I know that 3 is less than 35. The element at this index is less than 35. I don't know where should I search, because if 3 is less than 35 and the row and column both are sorted, so either my answer can lie on the right side as well as it can lie downwards. So I am not sure in which direction I should move. So this is not a correct place where I should put my element. Now suppose that if I will do what? If I'll put my element at this place. Suppose initially I'll start my searching from here. If I start from 69, so my element currently is what? 35. I want to search for 35. Now 69 is what? 69 is greater than 35. So I want to go to a lesser element. If I go up, then I'm going to a lesser element. If I go towards the left also, I'm going to a lesser element. But I don't know where I should exactly go. So this is also not a good position to search. Now, if you see here, let's say if I start from this particular cell here. Now, when I start from this cell, what can I identify? Now, this is a better place to start searching, because if you see, 38 is what? 38, like this is the last element of the very first row. So 38 is greater than 35. If 38 is greater than 35, so what does that mean? If 38 is greater than 35, this means that all the elements on the left of 35 are less, all the elements on the left of 38, they are less than 38. Okay, and as of now, the element that I want to search is basically lesser than 38. So I should go where? I should go firstly on the left side. So I'm able to decide one direction, that like I'm able to decide whether I should go towards the left, like towards the left direction or towards the downward direction. I'm able to decide one of the directions very easily. Suppose that if I had to check for what, let's say if my x value was equal to, let's assume 60 here. Now if I am here, so what is the advantage of starting from here? Now 38 is what? 38 is basically, guys, lesser than 60. If 38 is lesser than 60, all the elements on the left of 38 will also be lesser than 60. So I should go down. I should search in the downward direction. I should search in the next row. I should go to the next row in order to check for the element here. So this is the advantage that I'm getting with this, with respect to the first row last column, because it can help me to decide where I can go, because all the elements on the, like the element on the left are lesser than it, and the element on the downward direction, they are greater than this element. So that is why it can help me to decide based on the x value and the current element. Now if you see here, another place that I could have started is from here as well, because in this case, if you see, elements on the right side are greater than it, okay, and if I go up, the elements are lesser. So this could also have been my starting position, but to keep things simple, I will take my starting position as the first row last column. Now what will happen is we will start our I from 0, and then what we will do is we'll say that we'll be at the 0th row and we'll be at the last column here. Now initially we are starting from here, and at every step one row or one column will get eliminated. Correct. Now I'm at 38 here. Now what will happen is, if you see, the element x is what? Element x is basically 35. So 35 is what? 35 is less than 38. So I should search on which side? I should search on the left side. So I'll say that I will do what? I will decrease the, I will do what? I'll go on the left side. If I'm going on the left side, I'll decrease the column. So understand one thing, that if the element at the mat of ij, if it is what? If it is basically greater than the element x, then I need to search on the left side. So I'll do j minus minus because I want to decrease my element. So I need to go leftwards in the column. Okay. Otherwise, let's say else if what happens is if the element in the matrix ij, if it is, let's say, less than x, if the element is less than x, in such a case, what will happen? You need to go down because let's say if you will go to 30 here. Now, the moment you go to this element 30 here, now 30 is what? 30 is basically lesser than 35. So I need to go where? I need to increase my value. So I need to go downwards. I'll go downwards. So I'll increase my I value. I'll increase the row. So I'll do I plus plus. If the element that you are at, if it is less, then you need to go down. You need to increase the value. But if the element is greater, then you need to go leftward. You need to decrease the column. Okay, now you'll be at 52. Now you see that 52 is what? 52 is basically greater than the target element. So you need to search on the left side. So you will you will say that you need to go on the left because you want to decrease the value. So you'll decrease the column here. So what will happen? You'll go to 20 here. Now the moment you go to 20, 20 is what? 20 is less. So you want to increase the value. So you will say that okay, let's go down. Okay, in order to increase the value, you will go downwards in the row. So when you go down, you will go to this element 35 and you are able to find this. So you'll say that yes, I was able to find this. Now in the worst case, what will happen? How many rows and columns are you eliminating in the worst case? If you see, this is a two-pointer approach where I'm having one pointer I, another pointer j. So in the worst case, how many rows I will be eliminating? I'll be eliminating n rows in the worst case and m columns in the worst case. So the time complexity overall will be what? It will be order of n plus m here. Why? Because in the worst case, you can see that how much have I iterated? I went down these many rows and I went on the left side these many columns. So in the worst case, I'm iterating n columns and m rows. So order of n plus m is my time complexity for this particular searching approach here in the worst case. Okay, because in the worst case, I'll be eliminating n rows and m columns. Now, space complexity for this approach will be basically order of 1 because I'm not taking any extra space in this particular question here. Now let's see how we will do it. So you can see here that what I need to do is I need to initially have my row length and the column length. Then I start from the 0th row and the last column in that. After this, we will say that I should be less than n because we are increasing I. So I should be less than the n value and we are decreasing j. So j should be greater equal to 0 here. Now, if what happens is if the element that I'm looking for if the element that I'm looking for, if it is greater than my current element that I am at, so I need to increase the element. So I need to go down because if I'll go down, the value will increase because the row is sorted in the ascending order. So when I'll go down, I'll go to a higher value. If the current element is having lesser value compared to the expected element x, so increase the value. So go down in the row. Otherwise, if the current element is having a greater value compared to the target element x, in that case, what you will do is you need to decrease the value. So you need to go on the left side. So you will do j minus minus, you will decrease the column here. In the else case, if you find it, then return true. At the end, if your traversal is over and you have iterated n plus m times overall and you did not find the element, then in that case, you will return false. This false will be returned when you have eliminated n rows and m columns. So n plus m is the complexity in the worst case. Now let's try and submit this code as well. So let us submit this code now and see if it is getting accepted or not. So you can clearly see that my code was able to pass all the test cases. I hope that you are clear with this. Make sure to comment understood and thank you for watching this video.